Good. I started recording as well. So yeah, I'll begin from the first. So yeah, this white paper on cloud architectures, it's basically talking. It just starts out, uh, you know, uh, by talking about what cloud architectures are and things like that. The fact of the matter is that the way you architect applications in the enterprise inside data centers to that in public clouds is quite different. So it starts out with talking about the business benefits of cloud architectures. Capex becoming opex. Zero upfront infrastructure investment. And just-in-time infrastructure. Being able to get any amount of servers and cloud resources on demand with a single API call and things like that. More efficient resource utilization. Usage based costing, meaning that if you use a server, for example, in AWS for 1 hour, you pay only for the duration of 1 hour. You do not need to pay anything else. Potential for shrinking the processing time, meaning that because you are now able to create so many servers and run your applications and services in parallel. You will now be able to like do more number of tasks or run more number of apps and services, uh, and do a lot of parallel processing of data and things like that as well. you know Hadoop and big data, this type of applications are massively parallelize the task that is given to them, and run on distributed file systems, high speed distributed file systems on multiple machines, and join the results towards the end very quickly, and be able to process large volumes of data efficiently and fastly. There are various examples of cloud architectures that are talked about. Batch processing systems, pipeline processing systems, websites. you know you take any enterprise, most of the applications that the enterprises develop uh, you know fall into one or more of the categories of applications that are described here. So the fact of the matter is that for each and every category of the application, the types of AWS services that are used, and the way in which the AWS service, a subset of AWS services are used will be very different. For a data mining application, the set of AWS services that you can use will be different to a back office, batch processing system, that sort of a thing. So the paper goes on to talk about, by taking a simple example of grep the web. It talks about application architectures in the cloud. For example, if your company has an application called as grep the web, and this grep the web application would accept two inputs. One input is a regular expression, and the other input is a set of websites, and the output of the application is a subset of websites that contain the search string that you gave. So the regular expression that you want to search in all of the websites, um, you know the the if you give 50 URLs as input to grab the web application and provide a search string, which set of the subset of URLs among the 50 of them that contain the search string would be the output of your grep the web application. So your company has this application. Now what could be the architecture of this application, of this grep the web application in the cloud? It might look, there are many answers, there can be many solutions to the same problem. One such answer to this problem is this. So you can, there can be an Amazon SQS queue, you know SQS based application, queuing application, that would continuously take regular expressions as input from the user, And this SQS application talks to another Java application called as the controller, and this controller launches, shuts down, and monitor EC2 instances. And if and then the status of the amount of work, the status of the work, and the status of all of the servers that are created and shut down, and all of these types of things. The controller application uses AWS Amazon SimpleDB and saves the status of about the work that it is doing in this SimpleDB. Okay, and then on the EC2 cluster, you know uh, uh, the user the list of websites that the user wants us to search can be located inside an Amazon S3 bucket, and these EC2 instances read and write data to this S3 bucket, and the output of your program will be a list of URLs in a file that is located in the S3 bucket. So here we have architected an enterprise application using available AWS services, AWS SQS, AWS EC2, AWS SimpleDB, and AWS S3. So as a DevOps engineer, particularly if you are a senior or a principal level DevOps engineer, you will be tasked. You will be simply told, Krishna, we are going to write this type of an application. Can you please come up with a solutions architecture? An initial draft of what the solutions architecture can be for this solution. And then I would typically need to have a broad understanding of each and every AWS services, and come up with this type of a diagram based on my broad understanding of AWS services, and things like that. So this is an example. Okay, now let us look at the way the grep the web application, the various phases, how the grep the web application is being planned to work. The user gives a set of URLs and search string as input, and immediately there will be a launch phase. In the launch phase, the application would launch a lot of EC2 instances, all of them running grep the web application. But each EC2 instance would look for the string in 10 instances. So the launch phase, for example, I'm just throwing numbers for you guys to understand. So if the user gives 50 URLs in the launch phase, grep the web application launches 5 EC2 instances, and on the these 5 EC2 instances will run 5 copies of grep the web application. And the uh, input data set is 50, so each instance will take 10 URLs among the 50 URLs. Grep the web application splits it into 10 URLs each and gives it to the EC2 instances. Okay, these EC2 instances will provide whether the string is there in the subset of 10 URLs that is given to them. Okay, so that is a launch phase. The phase where application launches EC2 instances and running grep the web application is launch phase. And then there is a monitor phase, wherein the application continuously checks if the EC2 if the task given to the EC2 instances is complete or not. And then once the 5 EC2 instances do their work and report their status back, they will be shut down. And then any sort of files, temporary files, things like that are created in the S3 buckets are cleaned up in the cleanup phase. So that is the phases of your application. So if you zoom in a little more, keep in mind the phases of this application, and keep in mind the architecture of this application. Okay, So now if you zoom in further into the architecture of this application, you have to, your architecture, this architecture should implement all of these phases. And how is it going to happen? One such possibility is this diagram. Okay, so in Amazon SQS, you will be creating a launch queue, and this launch queue will be talking to launch controller. Okay, and this launch controller would be continuously reading and writing statuses to status DB. Okay, and the launch controller would be using a AWS EMR. Can anyone tell me what is AWS EMR? Sankirth, what is AWS EMR?
It's a Amazon Elastic Map Reduce, bro.
Mhm. What does it do?
So EMR is a Hadoop clustering tool that makes easy to manage and integrate with the Hadoop clusters.
Mm.
Hadoop is used for big data analytics through Elastic Map Reduce. It can integrate easily with other services such as Redshift and DynamoDB for data analytics.
Okay, good.
EMR.
So basically, so this launch controller application will be written using the Hadoop framework, Hadoop and HDFS frameworks. So this Hadoop application will run and launch EMR instances using EC2, and each EMR, each Hadoop application, would run mapping and reducing jobs. And then there can be another sub module inside your controller application called as the monitor controller, and this monitor controller would read and write, would read the status from the monitor queue, and the launch controller uh, uh, writes status, the cluster status to the monitor queue. And then once the results are out, the monitor controller would basically write a message to the shutdown queue, and the shutdown queue, uh, the message in the shutdown queue is picked up by the shutdown controller, which would initiate shutdown actions. And there is another application that is called as the billing controller, that uses a billing queue and controls the cost of operations for, it makes sure that there too many EMR instances are not spun up, things like that, so that the AWS bill won't increase, that sort of a thing. And then you have input bucket and output bucket in AWS S3. So like this, using multiple queues in SQS, multiple sub multiple services within your controller application, multiple buckets in S3 and simple DB, and using by spinning up Hadoop clusters in Amazon EC2, we have implemented the grep the web application. Am I clear? Are you guys following what I'm trying to say? This is how you think as a DevOps architect. When someone asks you how to run, most of the times, the people hire you so that, most of the times the employees of the company do not have knowledge of which AWS services to use, what service is useful for what applications, that type of thing. So as DevOps engineers, we need to step in and tell them that, hey guys, for this type of scenario, we need to use SQS. For this scenario, we need to use simple DB. For this scenario, we can use AWS S3. Like that, we have to propose, we have to tell the companies which AWS service to use, and in and in what configuration and format. Am I understood? Did you guys understand the architecture of this application?
Yes, bro.
Yes, Chaitanya.
Hmm. So this is how Hadoop works, guys. Basically, your Hadoop application will take a massive amount of jobs, a very big task as input, and it would parallelize the task that is given to it into multiple jobs, and it would run all of these jobs parallelly on multiple machines, virtual machines, and and join the results of all of the jobs and provide the result for the large data processing request made by the application by the user. uh, you know the process of breaking down and uh, parallelizing the huge data processing request is called as mapping, and the process of aggregating results from multiple in the Hadoop clusters, from multiple servers in the Hadoop that are part of the Hadoop cluster is called as reducing. So map and reduce. You can go to Google and learn Hadoop HDFS, HDFS file system, what is mapping, what is reducing, what is Hadoop framework, things like that. Go through the internet and read about it, and then you will be able to understand a little bit more. Okay. So, and another important concept is tight coupling and loose coupling in AWS. So if you have one application, one web application talk to another web application, and another web application talking to another web application, if this is your type of application flow, suppose web application B goes down for any reason, it can be any reason, but what would happen to all of the requests that application A makes to application B. All those requests would be throw would be thrown in the dustbin, and your application users, your company users will get 404s or 500s, that sort of a thing. So in order to avoid that, what if you write your application such that uh, your controller A, application A, reads from QA and writes to QB, and application B reads from QB and writes to QC, and application C reads from QC and provides output. If you write like this, you know if application B goes down, application A will still keep on writing messages to QB, and after 5 minutes, if application B comes back, it can read the messages from QB and continue where it left. It will continue processing the messages, so on and so forth. So you would be, if you this is called as loose coupling or decoupled architecture, and this is called as tight coupling. So if you more, this is kind of like a standard architectural pattern followed by applications in the cloud. You, instead of application API 1 talking to API 2 directly, API 1 writes a message to a queue and waits for a response, and API 2 continuously reads messages from a queue and writes back responses after processing the message. So this is kind of like an important architectural pattern in the cloud. Understood?
Yes, Chaitanya.
Chaitanya.
So go through this web white paper, and then if you have any doubts, we can talk about it later. So this is AWS cloud architectures. Mm, Yeah, this is another white paper on fault tolerance of applications in the cloud. Okay. So, this is a very common interview question in AWS, guys. How do you make sure your applications are highly available, and how do you avoid outages for your applications in the cloud, or how do you like what are the techniques? Amma, ettu, Nikki Gad. So, how do you make sure your applications are fault tolerant, or, how do you avoid outages? So, what are the techniques that uh, uh, in order to, so that, the applications and services, you can avoid outages for your applications? How do you keep them highly available? In various forms, typically people ask this question, but the answer would be all of the techniques that are given in this white paper. Okay, so let us look at how when you say uh, so like what is a fault, Mamata? What is a fault? Just plain English. There is no catch here. In English, what is the meaning of the word fault?
It's like what we say, unexpected bug or something like that.
Unexpected problem.
Failure. I mean failure, like failure. Yeah.
Okay, failure. Good. Narendra, what is tolerance?
like the the ability to work this in failure, like hello,
What is the word meaning of the English word tolerance?
the ability to work in presence of a failure.
Hmm. Some problem happens, you should be able to survive a problem. That is tolerance, right?
Yes,
So what is fault tolerance now? Ability to tolerate or survive a problem. That is fault tolerance, right?
Yes, Chaitanya.
Yeah. So what are the various techniques that are available in the cloud to keep your applications and services fault tolerant or highly available in the cloud? So these are the things that we are going to talk about a few things. Okay. Suppose you created a AWS account for your company. You created some EC2 instances. You manually installed and configured everything, and you are able to start your applications in your inside your EC2 instances, and your applications are running on EC2 instances. Suddenly something happens in Amazon, and Amazon sends you a message that your VM is lost. AWS is unable to recover or provide you the VM that you are running your applications on. and they you just get a message from them and say that we are not able to, we suffered a catastrophe and we are not able to give back the EC2 instance that is running your application or service. So please create a new EC2 instance and run your application. How will you be able to deal with that? Suddenly, something goes wrong, you lose your VM in EC2. What will you do? You should be able to create new servers that are capable of running your applications very quickly, right? uh, uh, Otherwise, you will lose a lot of time. Suppose you spend 2 weeks in creating and configuring all of the EC2 instances to run your company application. Now suddenly, after 2 weeks of hard work, you lost all those EC2 instances. What will you do now? Right? Do you guys get my point?
Yes, yes, absolutely.
So, what is an AMI, Narendra?
Amazon Machine Image, Chaitanya.
Okay, what does it have inside it?
Uh, we'll be creating instances from the AMI.
Hmm. What is an AMI? It is a bootable OS image.
Okay. Yeah.
What? Okay. గుర్తుండవు సావు. So one way to deal with this scenario is basically you can create an AMI. Suppose you take an EC2 instance, work on it, you configure all the things like files, directories, permissions, install packages, create environment variables, and all of these types of things. And now you know that you have the perfect machine that is capable of running your EC2 your company application. Then what you need to do is periodically create an AMI out of a running EC2 instance. AWS allows you to create snapshot of running EC2 instances, and one way to keep things to deal with to deal with failures in the cloud is to keep updated AMIs for each and every application. Okay, so uh, so AWS recommends you that you once you know that everything your application is running perfectly inside your EC2 instance, you create a snapshot and you create a AMI out of that running EC2 instance and keep it. So suppose AWS sends you that message that it is unable to recover your EC2 instances. Immediately you can launch the same number of servers that are originally running your application or service with the same AMI, and within few minutes you will be able to have 20 servers that you just lost, but their configuration and settings is in the desired state for running your application. So in this way you will be able to deal with you will be able to tolerate faults, if not avoid faults, you will be able to tolerate faults uh, uh, in the cloud. So that is one technique, keeping your creating AMIs out of perfectly running EC2 instances and keeping updated AMIs for each and every application inside your company is a technique for fault tolerance. Understand? Next is
Yes.
EBS volumes. Okay, now instead of creating an instance store backed EC2 instance, if you create an EBS volume backed EC2 instance, the root file system, the /root file system of your Linux operating system will be on a EBS volume. So even if the OS crashes and something like that happens, you can still have access to all of your files and the data that is that is saved inside of the VM by using these EBS volumes. So using EBS backed EC2 instances is another important fault tolerance technique in AWS. Okay, so you have 10 EC2 instances running your application in the cloud. How do you create backup of EC2 instances of your virtual machines? How do you create backups in for your EC2 instances? One way to create backups is to when you create the EC2 instances, create them to be EBS backed, and then once they are EBS backed, you will always have access to the root EBS volume that holds the root file system of your Linux machine, Linux VM. Are you guys did you guys understand what I'm talking about?
Yeah.
Okay, so another technique for fault tolerance in AWS is elastic IP addresses. Okay, suppose you have an application, and your application has talks to a database, but how would your application know which database to talk to? you know inside the Java code itself, you might have hard coded an IP address, and when you start your application, automatically the Java code tries to connect to the database running at that specific IP address. If your application is like that, these are all just scenarios. you know if your application is like that, uh, see, the important thing that you need to understand is there are three types of IP addresses in EC2. Can anyone name the three types of IP addresses?
Public, private, and elastic.
Very good. So can you define each type of IP address, Narendra?
Like public will be is the IP which is visible to all, and um, but elastic IP is one which we can attach to an instance, because every time we terminate and stop an instance and start an instance, the public IP will be changing. Instead of that, we can use an IP address which will not be changed, which is that would be an elastic IP.
Hmm.
And uh, private IP private IP is not visible, I guess.
Hmm. Who can complete Narendra's answer? Hmm?
I will tell you.
Hmm. What is a private IP?
So private IP address is the one which that is not reachable over the internet,
Very good.
and public IP is that which is that is reachable from the internet. So you can use public addresses for communicating between the instances and the internet.
Hmm.
And then elastic IP address is the one which can allocate to your account, like one particular account. You can associate it to and from instances as we require. And it is, I mean, the address that is allocated to our account
Hmm.
is an elastic IP address.
Hmm. Good. So basically, any EC2 instance that you create will have a private IP address. The private IP address, if you want to access the virtual machine from the public internet, the private IP address will not be enough. you will be able to create you will be able to connect to an EC2 instance from a private IP using a private IP when you are already inside a VPC. So suppose you are on a EC2 instance, and from one EC2 instance you are trying to connect to another EC2 instance. That time, since you are already inside of a VPC, you will be able to connect to an EC2 instance with its private IP. But if a VP, but you are trying to connect to a EC2 instance from the public internet, from your laptop, for example, outside of the VPC, then you need to the it is compulsory for the EC2 instance to have a public IP. Only then you will be able to connect it to it from your laptop or the internet, that sort of a thing. So typically, almost all EC2 instances, we create them with both public and private IPs. Okay, but there is a third type of IP called as the elastic IP. Okay, the difference of elastic the elastic IP is elastic IP is synonymous to static IP. Anyone remember what is static IP? Sanket, what is static IP?
Hello, bro. Are you able to hear me, bro?
Yeah.
Uh, static IP address is a number that assigned to a computer by an internet service provider.
Yeah. చి సరిగ్గా చెప్పు.
Static IP address is the address does not change.
అది address does not change when
most devices.
hey mamata tanta
Assigned static IP address does not change. Most devices when device is assigned when device is assigned to static IP address, that address is not changed.
ఏ చదువుకో సరిగ్గా లైనక్స్. రాముడు రామాయణం మొత్తం అయిపోయిన తర్వాత రాముడికి సీత ఏమైంది అన్నట్టుగా ఉంది నీ వ్యవహారం. సో suppose you have there are two types of IP addresses that we can assign to Linux virtual machines, right? One is DHCP, dynamic host configuration protocol, and then you can configure Linux servers with static IP. The difference between DHCP and static IP is that every time you reboot a Linux server, if its IP address is going to change, then it is DHCP. But if you assign a static IP to a Linux server, even if you reboot the server, after reboot also the Linux server will have the same IP address. The same way, if you reboot a EC2 instance in AWS, if its IP address is not going to change, and if the IP address is going to remain the same, then it is called as elastic IP. Okay, so you have to create elastic IPs separately in AWS and assign the elastic IPs to EC2 instances. Okay, so that is the process. If it is static IP, you can you can modify the Linux files, networking files, and restart the networking service on the server and be able to assign whichever static IP that you want to that server. But in AWS, it would generate a random elastic IP whenever you want. After you generate the elastic IP, you attach the elastic IP to the running EC2 instance. Okay, so basically, if you, for example, if a EC2 instance does not have a elastic IP, it only has a public and private IP. then if you reboot an EC2 instance, every time you reboot the EC2 instance, the public IP address of the EC2 instance will be different. But every time you reboot the EC2 instance, the public IP will be different. Whereas if you attach a elastic IP to a EC2 instance and reboot it, every time you reboot the EC2 instance, the elastic IP address of the EC2 instance will be same. Understand? Did you guys understand? Sanket?
Yes, bro.
So, in this example, I'm talking about fault tolerance, how elastic IPs can be used for fault tolerance of applications in the cloud, right? So, if your application is going to, if the database, if the IP address of the database which your application connects to is hard coded inside the Java code, instead of putting some random IP address of the public IP, some random public IP of the database. Of that your application needs to connect to, if you use a elastic IP inside your Java code, and you can suppose you started your application using an elastic IP, and that you attach the elastic IP to a RDS instance. Okay, Komali, what is RDS?
Hello. Hello.
Yeah,
Yes.
what is
Uh,
RDS?
it operates and scales the database in cloud.
Hmm.
Um,
So what you can do with it?
we can
చదవట్లా
check.
మైండ్ ఎక్కడ ఉంటుంది నీకు? You can create databases with RDS.
Okay.
AWS
Yes.
database as a service is RDS. You can create MySQL DB, Oracle DB, or Postgres, Aurora. There
Oh,
you can whichever database that your application needs, you can, with a single API call, you will be able to create using AWS RDS. Okay.
okay,
Suppose
sir.
for your Java application you are using RDS, and using a RDS instance, and you have attached a elastic IP to your RDS instance. Now, even if you lost the database, you know you can create a new database and attach the same elastic IP to the new database, and your application need not be restarted. Your application will continue to read and write to the new database, because it is using an elastic IP. You got this advantage. Otherwise, what is going to happen if you lost the database? Then you have to update the IP address of the new database in your Java code, and restart your Java application. Only then your application will be able to talk to your new database. So we can avoid this type of scenarios by using elastic IP addresses in the cloud. Did you guys understand what I'm talking about?
Yes, Chairman.
Okay, so let us take a look at auto scaling. Auto scaling is another mechanism using which you can cope up with faults uh, in your infrastructure. Okay, suppose you know you need 100 servers running your application, your company application, and only then you will be able to support all of the user traffic for your website, for example. But suddenly something happened, and you lost 30 servers. AWS allows you to to set up uh, auto scaling, so that in real time, in near real time, AWS would automatically add 30 new servers because you lost 30 servers. It will automatically add 30 servers even before you come to know that you lost 30 servers, and AWS has auto scaled your instances to added back 30 new servers because you lost these 30 servers and things like that. Before you can react, AWS will react in real time, because if you correctly enable and configure the auto scaling service. How will auto scaling know? Auto scaling is deeply integrated with CloudWatch. Okay, so in CloudWatch you can create an alarm saying that if the number of servers is less than 80, immediately add 10 more servers. uh, uh, you know for example, using the CloudWatch, using the CloudWatch metric monitoring that is happening on your EC2 instances, AWS will always know how many number of servers it is are running your application. Okay, using the CloudWatch metrics. Okay, and in CloudWatch you can create an alarm saying that if the number of servers is less than 80, trigger a auto scaling launch configuration. Okay, there is something called as auto scaling group, there is something called as auto scaling launch configuration. Okay, so auto scaling launch configuration will launch a auto scaling group. Okay, auto scaling launch configuration will launch a auto scaling group. Okay, and the auto scaling launch configuration is triggered by CloudWatch alarm. Okay, so the you all of your EC2 instances will have CloudWatch monitoring. The CloudWatch monitoring enables the CloudWatch service to get metrics, and you can create alarms for these CloudWatch metrics. And if the threshold is less than 80 in this example, the CloudWatch alarm goes off, and this CloudWatch alarm triggers a auto scaling launch configuration that launches a auto scaling group. And inside this auto scaling group, you can put all of the things like you create uh, 20 more servers using this AMI with 5 servers at a time. Like that, you can create a auto scaling group, and you can create an auto scaling launch configuration such that if the metric, if the threshold of this CloudWatch metric is less than 80, trigger the auto scaling group. Like that, you can set up auto scaling. So if you correctly configure the thresholds and correctly integrate CloudWatch, and these create these auto scaling groups and auto scaling launch configuration, you will be able to cope up with your application and infrastructure failures in the cloud. Did you guys understand what is auto scaling? These are all very, very important topics, guys. Pay attention. These are the special things in the cloud. And cloud computing and AWS means knowledge of all of these, the knowledge of the following concepts. Okay, make sure you clearly understand. Okay, so the next fault tolerance technique is elastic load balancing. Okay, so uh, elastic load balancers are also called as ELBs. Okay, so what you can do is, suppose you want to run your application on 100 servers. Okay, you can put all of the 100 servers behind an elastic load balancer in AWS. Okay, and you configure your route 53. Sankirt, what is route 53?
Is a highly available and scalable domain name system web service though.
What does it do? What do you do inside Route 53?
Uh, it will register domain names
Uh,
and route internet traffic to the resources for your domain.
Very good. Okay, so basically you can configure your DNS, your website DNS to point all of your user traffic to the Elastic Load Balancer. Instead of routing all of your traffic to your servers directly, you route it to your Elastic Load Balancer, and you put all of your 100 servers behind your Elastic Load Balancer. And then this Elastic Load Balancer has a program that will continuously and evenly distribute traffic to the servers behind it. So there will be an algorithm running on your ELB that will distribute, it will, if request 1 comes, it gives you to, it routes the request 1 to server 1, request 10 to server 50, request 25 to server 30. Like that, it will route, it will know which server is idle, and it will route the user request to the ideal server, things like that. Inside the ELB, you can also configure health checks, meaning that they if the application or service that is supposed to run on a server is down, your ELB will know through the application health check. Your Elastic Load Balancer will know that, oh, this something happened on the server, and the application or service is no longer running on the server. So ELB is smart. So if the health check fails for server number 30, it will stop sending user requests to server number 30. Instead, it will send it to 29 or 31. It will not send to 30. So it is a smart algorithm that is running inside the ELB, and it is very massive and scalable, massively scalable. So if instead of routing all of your exposing all of your company servers to real-time traffic, you can create a elastic load balancer, configure health checks inside your elastic load balancer, and then your application automatically becomes fault tolerant because of these health checks and the smart algorithms that are used inside your ELB for routing requests to only servers, to healthy servers, and things like that. Understand, guys?
Yes, bro.
Okay. So regions and availability zones. Okay, one thing that you need to always remember: the smart companies always deploy their applications in multiple regions and in multiple availability zones within a region. They will never deploy, or if you, for example, if you need to run your application on 100 servers, you will never create 100 servers in the same availability zone in a single region. Okay, you are going to create 50 servers in one region and 50 servers in another region, and within the region, if there are 3 data centers, you know you will be create distributing the 50 servers into the 3 availability zones. For example, you can create 15 15 or 16, or you can create 17 servers within one availability zone in a region, 17 in another availability zone, and 16 in the third availability zone. Collectively, you're running 50 servers in one region, but the 50 servers are again distributed into 3 availability zones. Okay, the same thing happens uh, to the servers in the second region also. So essentially, what is happening is, you are distributing the 100 servers into 2 regions and 6 availability zones. What is the advantage? Suddenly, the Amazon data center in one region catches fire, and suddenly, Amazon sends you an email that, all the servers that are running your applications in availability zone US West 1 are lost. Go create new servers in a new availability zone, and put your applications on them and run them. We are sorry. you know for AWS it is very easy to say we are sorry, but your company will be losing money because of AWS fault, right? So in order to avoid all of that, you know you have to do this type of things. You have to use ELBs, and you have to deploy your applications in multiple availability zones, things like that. So if your company did what I just mentioned, like, two regions and six availability zones, even though if all of the servers are lost in one availability zone, instead of losing 100 servers, your company is losing only 15 servers. Maybe you can configure auto scaling, and auto scaling will create additional 15 servers even before in other availability zones that are healthy. And then your application, your company is able to cope up with a AWS data center outage. Did you guys understand what I'm talking about?
Yes, bro.
Yes, Chaitanya.
Yes, Chaitanya.
Okay. So this process of building and deploying applications in multiple availability zones is also called as multi-AZ architecture. And then there are, one thing is I need to teach you guys about reserved instances. Okay, so there are three classes of instances in EC2, guys. So by now, all of you guys know that we can create EC2 instances or virtual machines in AWS, right? There are three classes of EC2 instances. One is reserved instances, the other one is on-demand instances, and the other one is spot instances. Okay, so what is what? Okay, what is on-demand instances? Okay, so whenever you want a new server, you make an API call, or you go to the AWS EC2 console, or you execute a AWS command line interface CLI command and create a new server. So the servers you create like this are called as on-demand instances. Okay, suppose you pretty much know that 24 cross 7 365 days a year, our company will will need 100 servers from AWS. Okay, instead of writing a program that creates 100 servers, and running this program once, creating 100 servers, and keep on using them 24 cross 7 365 days of 365 days a year, what you can do is you can go to AWS and say, hey, we know that we are paying X amount of money for running uh, these 100 servers all through the year. Can you reduce our yearly bill? Can you give us a discount? Like that, you can go to AWS and ask, because you are giving them a steady revenue for them. So what AWS people will say, yeah, yeah, sure, we will give you a discount. What we should do is we will convert all of your AWS instances, AWS on-demand instances, into reserved instances. Meaning that 100 servers, you will, whether you use 90 or you use 80, the bill you pay will always be for 100 servers. So like that, you can purchase reserved compute capacity from AWS and save monthly bills. As long as you use only 100, as long as you use 100 servers, your company will be saving money, because the on-demand pricing will be much more than the reserved instance pricing. But if you are underutilizing the amount of reserved instances, that is when your company is losing money. So that type of thing can happen. So you can convert on-demand instances to reserved instances, and pay less money to AWS, less monthly bill to AWS, things like that. But the catch here is you have to consistently use it 24 cross 7 and 365 days a year. So there is another class of EC2 instances called as spot instances. What is a spot instance means? You create an AWS EC2 instance, put your application and keep running your application. But AWS, whenever AWS needs additional compute capacity, it will steal the spot instance from you. So AWS will not tell you when it is going to take back the spot instance that it gave you. So suppose you have an application, that continuously converts Word files into PDF files. There is an S3 bucket full of Word documents, and it reads the Word documents and converts it into PDF files. This is the application. You create a spot instance and run this document conversion application inside it, and you deploy this application. It runs for 10 minutes and processes 10 documents, and suddenly AWS takes away the spot instance from you. What is going to happen? Only 10 documents inside your S3 bucket is processed, but nothing is going, you will not going to lose, you are not going to lose anything else. So you can write an application that continuously creates spot instances and runs this document conversion software inside it, that type of a thing. So the reason you can do such things in the cloud is because, for example, if a M4 2x large machine costs 47 cents per hour, if it is on demand, the same M4 2x large machine will be available for 5 cents an hour if it is spot instance. So your company will save a lot of money uh, by without compromising and using a less compute less powerful EC2 instance, just by using spot instances. Did you guys understand?
Yes, Chetan.
Yes, but
Okay. So reserved instances, spot instances, on-demand instances, all those things are covered. Okay. Now Amazon SQS. In the previous white paper, I was talking about tight coupling and decoupled applications, right? Instead of application one talking to another application, if we use if we write both the applications such that they read and write messages from queues, even if one of the application goes down, the other application keeps on writing to its messages, its request, it keeps on writing its request to the message queue, and once the second application comes up, it will be able to process them. This way you are making your application fault tolerant again. There are Amazon S3, Amazon SimpleDB, Amazon RDS. Amazon RDS also has a multi-AZ deployment feature, using which it will do automatic backups, automatic failover. If your primary database cache crashes, automatically it will fail over to a failover database running in a different region or availability zone, and things like that. You just need to click a button and enable that feature, and AWS will make your RDS instances or your application databases fault tolerant automatically. Go through the AWS RDS document and read about this multi-AZ deployment feature. It is an interview question they keep asking. So yeah, through this white paper I was able to teach you guys a lot of techniques that DevOps engineers should keep in mind while coming up with with architectures in the cloud for their company applications. Have you guys understood so far?
Yes, bro.
Okay, cool. So sounds good. So do you guys still want me to teach more concepts, or do you want me to break and we will continue tomorrow? What is your interest level?
We'll continue tomorrow,
There is
bro.
no hand trip available, Chaitanya. You can carry on.
Okay, sounds good. Yeah, we can continue tomorrow.